Hi, in this video we will do some examples for finding inverse of an invertible matrix using row reduction. Yes, so remember the first step is to form this augmented matrix. A on the left and identity on the right. Okay, and then start row reduction. Here, from left to right, move from left to right, and stop whenever you hit non-zero entry. Choose one of these to be your leading one. I choose this one to be my next leading one. So for that, choose it, move it, turn it to 1. So we have to move it now. Here, I interchange row 1 and row 3. So the row 1 becomes 1, 0, negative 1, 0, 0, 1. Row 3 becomes 0, 1, negative 1, negative 1, and then 1, 0, 0. Row 2, we don't touch it, yes? So this is row 2. Now, well, this is now in a good place. It is 1, so that's our first leading one. We have to use it and make everything else 0 in that column. This guy is already 0, so we have to make this 0 by multiplying negative of that entry, which is plus 2, and adding it to row. Also multiplying negative of that to row 1, the row with the leading entry, and add it to row 2. So this way, row 2 becomes 0 here, negative 1 there, 0 there. On the right hand side, we get 0, 1, and 2. Well, row 3, we don't change it. Row 1 is as before. And we are done with the first row. First leading one in the place, the column of the leading one is 0. Now we go to the next row and see non-zero entry. Choose one of them. I choose this one to be my next leading one. It is in the right place. We have to turn it to 1. So we can do it by multiplying the whole row 2 by negative sign, negative 1. So it is 0, 1, 0, 0, negative 1, negative 2. And the rest stays the same. Yeah. Now, this is our next leading one. We have to use it to make everything else in that column 0. This guy is already 0. We have to make this one 0. So how do we do that? We add row 2 to row 3. So this way row 3 becomes 0, 0 here, negative 1, 1, negative 1, and negative 2. Then row 2 stays the same, and row 1 is also the same. So this finishes our second leading one. We are good with that, and then we move from left to right. This guy is our next leading one. We have to turn it to 1, yes, so minus R3. This will make row 0, 1, and then negative 1, 1, 2. Then all the other rows, are as before. One, 0, negative 1, 0, 0, 1. Now we have our leading one in the good place. We have to turn everything else in that column 0. This is already 0. We have to make this guy 0. So this means that row 1, we have to multiply negative of that negative 1, which is plus 1, to row 3, the row with the leading one, and add it to row 1. So this will make this one 1, 0, 0, negative 1, 1, and 3. And the rest stays the same. Well, this is row reduced echelon form. And as you can see, this is identity. That means that A is invertible. And as our procedure says, the inverse of this matrix is exactly the right hand side of the augmented matrix after we turned it into row echelon form. So it will be negative 1, 1, 3, 0, negative 1, negative 2, negative 1, 1, 2. So this was the first example. Let's do another example of the forms that we have a variable in the matrix and we want to find values of k for which the matrix is invertible. So for these questions, we are interested in only seeing that if the matrix is invertible or not. So you can again start with doing AI, but at the end we won't be able to complete the whole process if there's a k in the system. So what we do in this case, we just use the fact that A is invertible if and only if it's REF, row reduced echelon form, is identity. So you don't need to do the augmented matrix. You just work with the matrix, this guy. Well, I mean, you can do work with AI, doesn't matter, but at the end, the information will be in this first part. So I start with this 1, 2, 1. 0k1 and 1, 1, 0. Okay, so start row reducing here. Well, this guy is in good place. I keep that 1, it is leading 1, so I want to make everything else 0. So this guy is the first thing. So we multiply row 1 by negative 1 and add it to row 3. So this will give us 0. This will give me negative 1. This will give us negative 1. And then everything else is there. Very nice. We are done with the first leading one. Now we move to the second one and we see, well, we move to right and, well, we see two things here, either k or negative 1. You may say, well, I can choose either k or negative 1 as my entry to be leading one. But how do you know that k is not 0? If k is 0, you cannot choose it. So k is variable. So in these kind of questions, better to keep k or choose the terms with k as leading one or to be leading one at the very last possible step. So it means that here I want to choose this guy to be my next leading one. So choose it, move it, turn it to 1, and then reduce the column using the 1. So to make this guy 0, this guy 0, I will multiply row 2 by negative 2 and add it to row 1. So this will become 1, 0, and negative 1. For this guy here, to make this guy 0, I can multiply row 2 by negative of, row 2 by negative of k, and then add it to row 3. You may say, how do you know k is 0 or not? Well, it doesn't matter. In this operation, row operation, if you multiply it by k and then add it, doesn't matter. It's just if it is 0, you're not changing R3. So this will be 0, then 0. This will become, so minus k plus 1. So 1 minus k. Then this stays the same. Nice. The second step is done. Now we move from left to right and choose. Well, there is one thing. There's only one term, and I have to choose to be that one to be my leading one. But here you have to ask yourself, maybe it is 0. So if it is 0, I cannot do anything. So this is the first fact. So here, if 1 minus k, that entry there is 1 minus k is 0, then we are done. Then this is row reduced echelon form. So this guy is 1, 0, negative 1, 0, 1, 1, 0, 0, 0. We assume that 1 minus k is 0. So this is row reduced echelon form, and it is not identity. So it means that for that value, and A is not invertible. While in terms of k, 1 minus k is 0 means that k is equal to 1. Actually, this is two-sided. So k, if k is equal to 1, then A is not invertible. Well, what will happen if 1 minus k is not 0? So this is the second case. If 1 minus k is not 0, then we can choose whatever number is. As soon as it's not 0, we can choose it to be our next leading one. So we can choose it to be the next leading one. And well, then use that one, make everything else 0. In other words, and proceed the reduction. So then we will turn that 1, 1, 1, 0, everything else in that column 0, and this will be identity. So for any number which makes 1 minus k non-zero, 1 minus k non-zero implies that the row reduced echelon form of A is identity, and as a result of that, A is invertible. So it means that for any number which makes k, 1 minus k non-zero, it means for any k which is not 1, A is invertible. Something that you have to be very careful, some people when get to this stage, they try to force this guy to be 1. That is wrong. This can be any non-zero number. You can turn it to 1. Yes. So let's say it is 2 here. 1 minus k is 2. While the next step, you multiply the whole row 3 by 1 over 2 and turn it to 1. So you should not set that 1 minus k to be equal to 1. That will be a number, an entry to be the next leading one. It need not to be equal to 1. Any non-zero number can be chosen to be our next leading one in that case. So that means that we have to consider 1 minus k being anything but 0. Okay, so this was another example. I just wanted to complete a few more examples, and these are the examples we did complete.